Hi everyone, today we're looking at Module 4, Lessons 18 and 19. And we're going to start with Lesson 18, the topic of which is that there is only one line passing through a given point with a given slope. So what that means is that when I have a linear equation and I pass through a certain point, there's only one line that can pass through that point with the exact same slope. So what we're going to focus on today is that students can graph equations in y equals mx plus b using slope and y-intercept. We're also going to make sure that you understand that if you have two lines with the same slope and one common point, then they are in fact the same line. So let's take a look at some graphs. I'm going to take a moment and sketch in some axes here that are going to be about 5 by 5 quadrants. And then I'm going to draw in some lines. Now take a look and see exactly where the points are that I'm creating so that you have the same line segments that I have. In that first graph, I have a 0, 3, a 2, 4, and a negative 2, 2. In that middle graph, I have a 0, negative 2, and then a negative 3, 0. And on the right-hand side, I have 0, negative 4, and then a 1, 1. So make sure all those lines are drawn correctly, and then we're just going to write in the equation of each line. This is all given information. Imagine you open up your textbook and you're staring at these three problems. So that first equation is y equals 1/2 x plus 3. The middle is y equals negative 2/3 x minus 2. And on the right, we have y equals 5x minus 4. And what I want to think about is where do the lines intersect the y-axis? Now remember, the y-axis is that vertical axis. So where do my lines intersect that axis? So where x equals 0, what is the y value? And just by observing those lines, I could see that my first intersection is at 0, 3, the second one is at negative 2, and the third is at negative 4, which also happen to be the final constant value in each of my equations. So in each equation, B is where the line is going to intersect the y-axis. And it's important to note that there's no variable attached to those numbers, so it is a constant, which means it will never change. So because we have an equation y equals mx plus b, and it gives us information about both the slope and the y-intercept of an equation, we're going to use this form most often when we are graphing equations. We're often going to use y equals mx plus b. And because of that, I want to look at kind of how we view slope on a linear equation using a quick example that's kind of generic. When I have my x and y axis and a line, I can create these horizontal and vertical lines to make kind of a triangle. You know how we've been using our slope triangle and saying, okay, how many spaces up, how many spaces over? If we label some points here, P, Q, and R, and then we talk about the distance between P and Q and the distance between Q and R, our slope is the distance between Q and R divided by the distance between P and Q. It's the same exact process that I would use when I count the number of spaces I have vertically over the number of spaces I have horizontally. Now, the visual here jumped ahead without me. My apologies for the error. But let's look at the second example on the right. I have an equation, y equals 2/3 x plus 1, and it tells me graph that line. The 1 is my y-intercept, so I'm going to plug that in as my b value right on my y-axis. And then my slope is 2/3. So I would go up 2 spaces, over to the right 3 spaces, and plot a second point. Now, all I need to do is connect those 2 points B and the point 3, 3 in order to get my line. I can also plug in the value of the coordinate 3, 3 into my original equation, y equals 2/3 x plus 1, to make sure it comes out as true. Moving on to Module 4, Lesson 19, we're talking about the graph of a linear equation is a line. And in this lesson, we want to have our goal be that students graph linear equations on a coordinate plane. So we're going to do something similar as we did with our last example. But this time we're just going to choose some random values for x and solve for y. So let's say that I have this equation. It's going to be x plus 2y equals 6. And we're going to graph that line by using some x values. X equals 4 and x equals -4. And we're going to use them to find solutions to the equation x plus 2y equals 6. So first of all, I need to substitute in 4 for x. So 4 plus 2y equals 6. And I solve for y. So subtract 4 from both sides. I get 2y equals 2. Divide both sides by 2. So y equals 1. So when x is 4, y is 1, and I have this coordinate point 4, 1. I can repeat this process with substituting in the x value of -4, solving for y, and I get y equals 5. So when x is -4, y equals 5, and I could plot that coordinate point. Now it only takes 2 points to draw a line. So once I have those 2 coordinates, I have essentially graphed my line. Then what you can kind of do is look and see on your line, is there a nice even coordinate point? So for me, I'm looking at 3, 2. Is that coordinate point on the line that I drew? So I plug in my original equation and check to see if it's true. In this case, it's not true because when I plug in 3 for x and 2 for y, I get 3 plus 2 times 2, which is 3 plus 4. That equals 7, not 6. But what you should notice through this example is that a linear equation can be graphed using only 2 points. I don't need a slope, I don't need a y-intercept.